Hey guys, Mrs. Duncan here. Hope that you guys got out yesterday and enjoyed the sun. It was gorgeous outside, so hopefully you enjoyed your weekend. I'm going to do a quick lesson on percent concentration and dilution. Okay, so percent concentration is just the amount of solute divided by the amount of solution. So remember that solute is present in the lesser amount. It's what's being dissolved. And then the solution is what the solute and the solvent make together. Together they form that solution. So whatever the amount of solute is divided by the amount of solution. Okay, and this is going to be represented as a percent. So mass percent means that you could have mass of solute over mass of solution. You could have volume percent. You could have volume of your solute over volume of your solution. You could have a combo. You could have mass over volume. So you'll see little letters here. MM is mass over mass. VV would be volume over volume, or MV would be mass over volume. So again, it kind of depends. It's all just saying, though, that you have a percent concentration of your solution. So whatever information is given to you, you can plug that into this equation here. Okay, so let's look at this, for example. One thing that I want you guys to note, so this would be, again, how do you find mass percent? You take the mass of your solute divided by, be careful here, because sometimes the mass of your solution is given to you as just the mass of your solution, okay? In that case, you can plug that right in. Other times, though, guys, your solute and your solvent are given to you separately, and you would have to add those up. So that's one thing that you want to pay attention to when you're doing this equation, is how is the information given to you. So for example, if it said that I have 100 grams of salt and I add that to 100 grams of water, okay, my mass of solution is not 100 grams, it would be 200. Mass of the solute plus the mass of the solvent. So if it tells you that it's adding something to water or something like that, pay attention, because you'll need to add those up to get your solution. Or sometimes it just may say, I have 100 grams of salt in a 200 gram solution. Okay, in that case, you can just use what it gives you. So please be careful when looking at the information given to you. And I mentioned this before, and I'm going to mention it again. This doesn't necessarily have to be grams and grams. It can be, but it can also be milliliters and milliliters, okay, volume over volume, or it can be grams and milliliters. So just because I'm using mass percent as an example doesn't mean that's all you're going to see. You could see a combination of mass and volume, okay? So let's look at an example of what this would look like here. Okay, so what is the mass percent of a solution prepared by dissolving 30 grams of sodium hydroxide in 100 grams of water? This is an example in which your solute and your solvent are given to you separately. So 30 grams is the mass of your solute, so that would be your top number. But guys, 120 is not the mass of your solution. Your solution would be these two added up together. So your solution would be 150. So when you do this math, you're going to take the solute, which is 30, divide that by the total solution, which is 150, and then you're going to multiply all of that times 100 to get your mass percent. So this is what this would look like. 30 divided by 150 is 0.2, and then times 100 to get your percent. So this would just be 20% of sodium hydroxide. So what that's saying is that's how concentrated, that's how much sodium hydroxide is in this example problem, okay? So again, I know that this is kind of fast, but just take you and plug in your solute, which is your smallest number, your solution, again, could be solute plus your solvent, or it could just be given to you, and you're just going to divide those out. You could also potentially solve for one of these. So like, for example, I'm going to pull up a blank screen here. I'm going to make something up. Okay, let's make up my own problem here. All right, let's just say that I have a 40% solution, and that's my percent, and I want to know the amount of solute in 300 grams of solution. Okay, so when you think about your mass percent equation, there's technically three variables. You have your percent, you have the mass, or I'm going to put volume because you could have volume of your solute over the mass, again, or volume of your solution. So there's three variables here. There's this variable, and this variable. So as long as you're given two of those three, you can solve for the one that you're missing. So the case that I just did, we just did solute over solution, and we solved for percent. But what if it gave you a percentage and it said, okay, well, I want you to solve for solute. Okay, again, you would just plug in what you know, which would be your percent and your solution, and then you would go from there. So when you are talking about doing math with a percent, you need to take it out of percent form. So when you take something out of percent form, you can do two things. You can take whatever your percentage is and divide by 100, or you can just take and move your decimal place twice to the left. However you want to do it and however you're comfortable with it, that's fine. So if you are given a percentage to use to solve for something over here, then you're going to take it out of percent form. Okay, so let's switch colors here and let's plug this in. So I would have 0.4 equals, I don't know the mass of my solute, so I'm just going to put grams of solute on top. And then I'm going to divide that by my grams of solution, which this told me was 300 grams. Okay, so I'm going to solve for this top number. So at this case, this is just algebra. How do you solve for this top number? Multiply both sides by 300. So 0.4, which is your percent, times 300. And you can get your calculator out if you need to do that. And your final answer is 120 grams of solute. Okay, so that was an example where you were not solving necessarily for percentage, but you were solving for the solute. And again, you could solve for the solution. It could give you percent and it could give you your solute, and then you would just solve for solution. So however it gives it to you, pay attention to, first of all, what have you been given? How have you been given it? Have you been given grams? Have you been given milliliters? And pay attention to that solution aspect. In my example problem, I just said 300 grams of solution. But if I said, X number, that would have been harder to do when I'm solving for solute. But just pay attention to how is the information given to you, and think about this as just an algebra equation. You have three variables. As long as you have two of them, you can solve for that third one. Okay? All right, so guys, that's just percent concentration. So that's just giving a percent as to how concentrated something is. Okay, obviously, the higher the percent, the higher the concentration is, okay? All right, let's go back to our thing here. So that's mass percent or percent concentration. Again, that could be mass volume, or mass. It can be any which way. Okay, and the other thing I want to talk about really quickly is dilution. Okay, and dilution is a process where you make something less concentrated. You generally add water to it. Water is generally what's used to dilute something, but you're going to make a larger volume of it without really changing the amount of solute that you have. So anything that you add water to in order to dilute it would be something that maybe you would see, for example, you have that frozen orange juice and you pour that in. This is not something that you would want to drink straight from the can. It's crazy concentrated. That'd be really, really gross. So what do you do to it? You add more water. not only are you adding water, so you're creating a larger volume, but you're not changing the amount of orange juice that you're putting in. Okay, if you added orange juice and water, that would defeat the purpose of dilution. So you're just adding water to this to dilute it and make it taste better. Same thing, maybe you've tasted it the other way. Maybe someone had lemonade at a barbecue and it tasted really watered down. Okay, that would be an example of over diluting something. They added too much water and it really mellowed out that taste. So dilution is just taking a really concentrated solution and adding water to it in order to dilute out that concentration. It makes it less concentrated. And if you're talking about a drink, then that would be much more enjoyable to drink. If it's over diluted or under diluted, then that's not going to lead to a very good drink there. Okay, so again, I just mentioned this, but the amount of solute does not change. So you're adding more water. So you are having more volume. Okay, that makes sense. If you're adding water, you're adding volume. But it's decreasing the concentration because the solute is not changing. So the amount of solute in the concentrated solution is the exact same amount of solute you have in your dilute solution. The only thing, sorry about that. The only thing different is the amount of water that's been added to that. So you're going to have a dilute solution because your amount of solute is not changing, but the amount of water is. Okay, so your amount of solute does not change before or after. So again, I'm going to go back to my orange juice example. When I dilute it, I only add water. I have the same amount of orange juice before and after. The only difference is I added water and diluted it to make it a much better drink. Okay, so the amount of concentration depends on how much solute there is, the volume of your water. So how concentrated it is going to depend on those things. So technically, an overall equation for this would be C1 times V1. So that's your concentration, your initial concentration, times your initial volume equals your final concentration times your final volume. Okay, so concentration for this is mostly going to be in molarity, or it could be a percent. So I just talked about percent concentration. So you could be given percent concentration, or you could be given molarity. So C1 V1 equals C2 V2 is the same equation as M1 V1 equals M2 V2. This is just specific to molarity, whereas this one, you could have it in any concentration. That could be molarity, it could be percent, you could have parts per million. So this is a very general equation. This is just specific to molarity. So both technically are the same thing. So most of the time, though, these are the two ways that you will see concentration most often. And even then, molarity is probably going to be one of the number one, especially with chemistry, ways that you see something as concentrated is going to be expressed in molarity. Okay, so let's do an example problem here. So what is the molarity of a solution prepared when 75 milliliters of a 4 molar potassium chloride solution is diluted to a volume of 0.5 liters? Okay, couple things in here that I want you to pay attention to. First of all, it's asking for what is the molarity. So we know that we're solving for molarity. It's telling you that you have an initial molarity of 4. Okay, and we're diluting that down. So even without solving for all of this, I know that my final answer is going to be less than 4, because what does dilution do? It dilutes, it makes it less concentrated. So if my dilution, my procedure is that if it works, then it's going to be a molarity of less than 4. So it's telling me this is my concentrated solution. I've got 4 molar. And I have 75 milliliters of that. And I end up with 0.5 liters. And again, that's just a tricky way to make sure you're paying attention. Guys, it does not matter if volume is in milliliters or liters. They just have to be the same thing. Okay, so you can either change milliliters to liters, which is what I did in this problem, or I could have easily changed this to 500 milliliters. Either way is fine. It doesn't matter, but just make sure that both of your volumes are in the same unit, whatever that looks like. So if we look at this in milliliters, and sometimes milliliters is a little bit easier to visualize because milliliters is just a smaller unit there. And a lot of the pop that you buy and all that, that's in milliliters. So it's kind of easy to think about. So I went from 75 milliliters to, if I change this to milliliters, to 500 milliliters. Well, that makes sense. My volume got larger. Why did my volume get larger? Because I diluted it. Well, how do you dilute it? You add water. So it makes sense that my volume is going up and my molarity is going to go down. That's what dilution is. Volume up and then concentration down. So I'm going to plug this in. My initial molarity is 4. My initial volume is 75 milliliters or 0.075 liters. So I just moved my decimal 3 times to the left. So I turned that into liters. That equals, I don't know M2, that's my X. And then my volume 2 is 0.5 liters. And again, I'll say it one more time. It does not matter if your volume is milliliters or liters as long as they're in the same unit. Okay, so we're going to plug that in. How do you solve for M2? Multiply both of these and divide over by 0.5. So when I do that, my final molarity is 0.6. Is 0.6 less than 4? Yes, it is. So that makes sense that my molarity went down because that's what a dilution does. Okay. Also, guys, another thing I'm gonna make up another problem here just to show you. Another thing when it comes to molarity or dilution, so we have M1 V1 equals M2 V2. Okay, let's just say that my problem, I have initial molarity. Let's say I have an M1 of 6 molar. I have an initial volume of 25 milliliters. Let's say I'm solving for my M2. And let's say, guys, that in the problem it says you have 25 milliliters and you add 100 milliliters of water. Okay? Again, pay attention to the wording here. 25 milliliters is my initial volume. Guys, 100 is not my final volume. Why? Because if I had 25 and I add 100 to it, my total is 125. So my final volume would be 125 milliliters. So again, pay attention to how the problem words it, because if you add water to it, whatever you're adding is going to get added to whatever you initially started with. So just because you see 2 volumes, don't automatically assume that this one's 25 and this one's 100, because again, you're adding this to it. So pay attention to the wording here. So now once I have all of my final numbers here, I'm going to just plug in. I've got 6 molar. Okay, there's my M1. 25 milliliters is my V1. I don't know my M2. And my final volume was 125. Again, milliliters is a total acceptable choice for this. So what do I expect? I expect that my molarity goes down because I am diluting it. My volume went up. Okay, so I had 6 molar, so 6 times 25 is 150 equals M2 times 125, divide over 125. And when I do that, 150 divided by 125 is 1.2. So my molarity, my final molarity is 1.2. Okay, is 1.2 less than 6? Yes, it is. So I know that makes sense. Okay, when you're diluting something, you shouldn't have a higher concentration because that's not what dilution is. Okay, the last thing I'm going to mention really quickly too, guys, is that you could potentially have percent concentration as the way that it's given to you. So if you had, let's say you went from a 60% concentration and it's asking you what's your new concentration, when you plug this in, again, when you're dealing with percents, make sure that you take it out of percent form. So your first concentration would be 0.60. Okay, Okay, I'll just make up numbers. Okay, so my initial volume, let's say, was 100 milliliters. And I'm going to go, I don't know my second concentration. And let's say that I'm going to go up to 1,000 milliliters. Okay, so this is no different than what you've been doing. Just again, note that because this is a percent, when you plug that into your equation, so this one, again, M1V1 equals M2V2, C1V1 equals C2V2, it's all the same, it's just however concentration is given to you. So because this is 60%, I'm going to take it out of percent form. Okay, so you actually want to take 0.6. You're going to multiply that times 100, which is 60, equals, I don't know my C2, and I'm going to have that, I'm going to end up dividing 60 by 1,000, so 0.06. Okay, that's your second concentration, but you want to put that back into percent form. So multiply by 100 or just move that decimal point 2 more times, so 6%. Okay, so I went from 60% down to 6%, which that makes sense. As a dilution, my concentration got less. So this was just another side note. If you are given percent concentration, take it out of percent form to do your calculation, and then put it back in percent form if you're trying to find that concentration for C2. And again, guys, it doesn't matter. You won't always solve for concentration. Sometimes it'll ask you for a final volume. You could solve, it could tell you, here's my initial volume, here's my final concentration and my final volume. What was my initial volume? In that case, if you were solving for M1 or C1, depending on how it gives it to you, then you would expect that number to be higher, because when you're diluting it, if it gives you, so let's just say, for example, I had a 5 over here, 5 molar, I would know that my initial molarity would have to be higher than 5. So your final volume is going to be higher, your final concentration is going to be lower. So as long as, again, think of this as an algebra equation. You have 4 variables. As long as you're given 3 of the 4, you guys plug in what you know, make sure that all of your units match up, and you are good to go. So that is molarity and dilution and percent concentration, and how all of those are connected to each other in terms of when you are trying to report out a concentration for a solution. All right, nice job, guys. Thanks.